Okay, so in this quick video, we're going to go over the basic steps of the water cycle, how water moves through the atmosphere. So let's go ahead and get started. Well, titled here I have the hydrologic cycle, which is just a fancy way of saying the water cycle. Now, when I look at the water cycle or the hydrologic cycle, its definition is simply the movement of water through the atmosphere. So when we look at a picture of the Earth here, we can see that the vast majority of the surface of the Earth is covered by water, about 75%. The problem is the majority of the water that is on the surface of the Earth is undrinkable. The picture on the left is just a picture of salt, implying salt water. The picture on the right shows some frozen glaciers and icebergs, and so most of the water is undrinkable because it's either too salty or frozen. So when we talk about water conservation, keep in mind that there's about 7 billion people on Earth drinking from a very small percentage of fresh drinking water. Well, let's go ahead and look at the stages of the water cycle. So when we look at the stages of the water cycle, water rises into the atmosphere in one of two ways. Probably the most obvious one is through evaporation. And in the animation, I have H2O standing for water, water rising out of this pond into the atmosphere. And that's simply called evaporation. Heat from the sun causes liquid water in the pond to turn into a gas form. So water goes through a change of state from a liquid to a gas. A second way that water rises into the atmosphere is through what's called transpiration. Transpiration is where plants lose water through their leaves. Let's actually look at that in a little more detail. So one thing I want you to know when we focus on transpiration in a little more detail is that plants have these little pores on the backside of their leaves. Well, here's a picture of a plant leaf, and let's go ahead and zoom on in with a microscope so we can get a closer look at what's called their stomata. And here's one single stomata here, or stomate for singular. And what we see in the animation is water evaporating from this stomata here. And these stomata have the ability to open and close, and plants will have hundreds of these per leaf. And these stomata can open and close, and this is how they exchange gas. So you know that plants need carbon dioxide in order to do photosynthesis. So when the stomata are open, they can take in carbon dioxide. And I think you know that plants also give off oxygen when they do photosynthesis, and so when the stomata are open, oxygen can escape from the leaf. Well, when the stomata are open, it's not just oxygen that escapes, but also water vapor. And so this is transpiration in a little more detail. It's where plants lose water. They lose water through evaporation because these stomata are opening and closing throughout the life of the plant. So here we have our animation showing evaporation and transpiration. Well, all this water, as it rises into the air, collects in the atmosphere. And so over time, water begins to build up and collect. Again, this is water vapor, gas. Water gas builds up and collects in the atmosphere. Well, what happens next? Now that there's a bunch of water vapor collecting in the atmosphere, this leads to a process called condensation. This is where the water is going to turn from a gas back into a liquid. And the cause of this is cool temperatures. Let's take a break from the water cycle for a moment and just focus on an everyday occurrence that you probably have seen 100 times. Here's a bottle, a soda bottle, on a nice hot sunny day. Let's say you're drinking some soda outside and you put the bottle down for a few minutes, then you come back a few minutes later. You might notice that little droplets of water have accumulated on the outside of the water bottle. Where did the water come from? Did the bottle leak? No. The reason there's little droplets of water is because that water bottle, that soda bottle, is really cold. You just took it out of the refrigerator. And so the moisture that's in the air came into contact. Moisture in the air came into contact with that cold bottle and it condensed, forming little liquid droplets. Well, if we relate this to the water cycle, By relating this to the water cycle, that is how we see clouds form. Clouds are the results of condensation. Water vapor will condense and form clouds. And when the liquid water of clouds gets heavy enough, of course, it will rain. And so when we look at the next stage of the water cycle, we have precipitation. And in the animation, we have water, H2O, falling out of the cloud. Well, when we look at precipitation, there's different types of precipitation. The most obvious being this picture here of rain. Here's another picture of precipitation, snow. And here's a form of precipitation called sleet. And if you're not familiar with sleet, it's kind of like a frozen rain. Sleet is actually very slippery and hard to drive on because it's also, you might hear the phrase black ice, because when water freezes on a road, you can't even really see it, and so the road might look clear, but it's really a real thin layer of ice on the road, very slippery, hard to drive on. Be careful. And then a fourth kind of precipitation called hail, little small balls of ice that fall from clouds. And here we see a person holding some hail in their hand. Now the ones in this picture here are not common. I'd say the usual size of hail is smaller than peas. So the hail balls are usually not as large as the picture here. But when they are, they can cause some damage. You look at this picture right here, you can see the back window of this automobile broken because of hail damage. So now that water's on the ground, so it's been raining or sleet or some kind of precipitation, now that water's on the ground, what happens next? Well, water's going to do one of two things. Notice in the animation, water is simply running downhill, and that's simply called runoff. So when water hits the ground, it's going to roll downhill into a river, into a lake, into an ocean. Water is going to roll downhill into its lowest point, which eventually is probably going to be one of the oceans. Well, as water is running downhill, it also might soak into the ground, and that's what the word infiltration means. When water hits the ground, it can soak into the soil, and this will create what's called groundwater. So in our animation, we have some H2Os accumulating under the ground, and this is where a lot of the world gets their drinking water from, is from groundwater. Let's look at that really quickly in a little more detail. When we look at this picture here, we can see kind of a cutaway of the surface of the earth, and then underneath the surface we see the flow of groundwater. Well, what we often do is we'll drill wells down into the groundwater supply, and that will supply drinking water and cleaning water and bathing water. Well, you might wonder, well, if we drill down and make wells, won't we run out of groundwater? Well, the reason why we don't run out of groundwater is because of infiltration. When water soaks into the ground, infiltration will replenish or recharge the groundwater supply. So let's come back to our animation here, and let's just kind of show all the steps at once. So here we have evaporation, water evaporating from this pond, and now I've added transpiration, water evaporating from the leaves of the tree. And so as the water goes up, eventually it's going to form clouds, and clouds are the result of condensation. When the gas when water gas turns back into a liquid gas, I said that wrong. When water gas turns back into a liquid, that's called condensation. And eventually that liquid gets heavy enough where it falls as precipitation, whether it's snow, rain, sleet, or hail. And once water is on the ground, let's say it's rain, once it rains, water is going to do one of two things once it's on the ground. It's either going to run off downhill, or it's going to soak into the soil. But if you look in the animation here, we have a cycle, a continuous around-the-clock cycle here known as the hydrologic cycle or the water cycle. So I'm going to just let this play for a few moments before we conclude with a little practice quiz. Okay, so here we have a practice quiz. Go ahead and pause the video, and if you're in my class, try to answer these questions on a separate sheet of paper and bring them to me. I'd love to check them for accuracy. So go ahead and pause the video and try to answer these. Good luck.